And although we can't hear a thing, it's among the loudest sounds in the animal kingdom. Loudest, and if read properly, the most precise. In China, one elite corps of bats has upped the stakes. They won't settle for just bugs and spiders. As Ricketts' big-footed bats emerge from their cave, they start to pulse their sonar at a rate of 20 calls per second and can quickly exceed 90 pulses per second. Like the shriek of a missile, the Bat Battalion's sonic sweep increases to a staggering 150 calls per second just before the Special Forces strikes its target. Their call can penetrate the water's surface, which is the point of their mission. She glides over the surface and strikes. Target secured. Mission accomplished. A tasty fish for dinner. She can consume up to half of her body weight each night. If she fails, she'll have to slow her metabolism during the day or risk becoming too weak to hunt. That doesn't happen too often in this squadron of highly skilled sonic soldiers. From the forests of Asia, we head to the interior of the world's smallest continent to meet our next elite corps of surveillance specialists. The moist soil is a much better conductor and a much better place to conduct business. It doesn't hurt that the floor of the forest is teeming with targets. The echidna's snout is formed by elongated jawbones and is lined with olfactory nerves. Scent is so important that almost half her brain's sensory region is assigned to processing fragrances picked up through her snout and tongue. Every living creature emits slight electrical fields every time a muscle twitches or a nerve cell fires. Depending on the genus, an echidna can have between 400 and 2,000 electroreceptors in the tip of its snout. These receptors alert the hunter that her target is near. Other groups of receptors in her snout, called Merkel cells, sense movement, alerting her when she makes contact with her meal. Echidnas and elite corps are the only ground-dwelling vertebrates known to have electroreceptors. Platypuses and one species of dolphin are the only other mammals with this talent. Once she locates the nest, she digs in. Before the termites realize the danger and retreat, the echidna can gorge herself. Sooner or later, however, she'll have to tear into the depths of the nest, guided by her electroreceptors. For For this Special Forces soldier to get top performance out of her array of high-tech sensors, she keeps her snout tip wet with nasal secretions. The wet nose increases electrical conductivity and assures her success. And since termites try to maintain high humidity in their mouths, that only helps the echidna to pursue them like a bunker buster. Another day, another satisfying search and destroy mission for the echidna and her electrifying weapon. Leaving the Australian mainland in search of our next elite corps of specialists, we follow them to the Pacific Ocean and one of the world's most remarkable natural wonders. The Great Barrier Reef. Stretching almost 350,000 square kilometers, it's the starting and end point for an epic migration of magnificent mammals that communicate below the range of human hearing. The humpback whales. Big as school buses, these special forces live in pods of 2 to 3 or as many as 15. And they have plenty to say to each other. While bats' ultrasonic screeches are too high for us to hear, some songs of the humpback whale are too low, produced in the infrasonic range. Whales produce the loudest continuous sounds of any animal, while blue whales can be as loud as a bomb blast. Humpback whales, the second loudest, can bellow as loud as a convertible in a highway. And they can keep it up almost continuously for one full day. Their deep calls can travel through the water for hundreds of kilometers. All baleen whales, including humpbacks, are known to sing, especially during the breeding season. Adult male humpbacks produce the longest and the most complex songs. Groaning, roaring, chirping, and sighing for up to 30 minutes and stopping only to take a breath. He might repeat his song several times for more than 20 hours. Each humpback has its own vocal signature, and fellow humpbacks can recognize him by his song. The whale sends out its subsonic song below the range of human hearing. The sound waves meant for communication bounce off obstacles. Though a whale has tiny ears, it picks up the vibrations through its fat-filled jawbone. The sound gets transmitted to a seashell-shaped ear bone called a bulla, where it gets amplified. This elite corps has made its way to cold waters of Antarctica, about 5,000 kilometers away. It's time to put their communication skills to good use. Starving after the long trip, these special forces coordinate a hunting expedition. All the soldiers man their battle stations. The operation begins. One of them dives, emits the sounds, and blows bubbles to scare herring up from the depths. The rest get ready to strike the frantic herring when he herds them near. bubble net prevents the little fishes from escaping. It's an effective technique. Since an average humpback eats 1,300 kilograms of food each day, the elite corps benefits from their low-key, acoustically coordinated attacks. It enables one of the biggest animals in the sea to survive by eating some of the smallest ones. When selecting an undersea ultrasound expert who's a team player, the humpback whale makes a sound choice. Back to Australia, where the whale's naval deployment began, we delve once again into the forest and set our sights on locating a tiny terror. In the forests of Australia live an elite corps of hunters that perfectly stands out. Most spiders use vibrations and touch through their silky webs to orient themselves during the hunt. But there is an exception. Jumping spiders rely on vision, and these ninjas see things a little differently than we do. Their mission: to close in on a target without being seen, then leap and overpower their unsuspecting prey. To pull it off, these special forces need to gauge the distance precisely. With the element of surprise, they can even take down spiders bigger than they are. It's all about depth and color perception, thanks to their wide-spaced eyes that see light across the visible spectrum and also ultraviolet. As the moon shines over the jungle, a Portia spider plans her attack. Her stealth is her strategy. See, but don't be seen. Target: a jumping green spider. But her mission's been compromised. This spider is also a jumping spider, who has the Portia spider in her sights. Since both species have excellent vision, the surprise is ruined. The Portia tries to fool the opponent, but without success. Mission aborted. She'll have to find a more suitable target. In the meantime, on the forest floor, a battle of the sexes is taking place. Peacock spiders, about the size of apple seeds, are trying to find a mate. They rely on their elite spider vision. This elite corps has 4 eyes in a row, 2 large main eyes in the center, and 2 smaller ones on each side. The side eyes sense motion, while the main eyes zero in. Thanks to layers of photoreceptor cells in their main eyes, the peacock spider can see a wide range of light. The first layer at the surface detects ultraviolet. The second detects blue, and two deeper layers are sensitive to green light. True to their name, male peacock spiders are colorful, and the species is rare in its ability to see red, yellow, and orange. The officer with the best moves and boldest colors wins the right to mate. Elsewhere in the forest, the Portia spider seems to have found a new target. Prey that reflects ultraviolet light usually catches her eye. She can see a broad spectrum, from UV through deep red. Today, she spies the St. Andrew's cross spider, almost twice her size. She plans her strategy. Step 1, she has to be very precise, relying on her sharp eyes to orient herself among the branches. Step 2, lock on and wait. The cross spider doesn't suspect a thing. The Portia has to be sure it stays that way. Step 3, assess distance and strike. One venomous bite does the trick. After completing her successful mission, the Portia waits, ready for her next target to come into view. In wildlife's battles, some warriors come better equipped for the fight than others. Each of these special forces brings advanced weaponry to the front. Sharks with the ability to smell a drop of blood in 100 liters of water lock onto their targets by constantly circulating water through their ultra-sensitive olfactory organ. The barn owl doesn't rely on smell, but sound. With a face like a satellite dish tuned to the frequency of her prey, she can fly under the radar thanks to fringed wings. Tuna, the sharpshooters, trust only what they see, keeping a sharp eye out, focusing on the kill zone ahead and above them. Some can see subtle colors and small targets at 30 meters. An elephant's secret weapon is its gracefulness. With more than 150 times more muscles in their trunks than we have in our entire bodies, these enormous tanks are outfitted for assignments that require both subtlety and brute force. The rattlesnake is just as graceful, though much harder to spot, as it constantly samples the air for a scent of its supper. Its Jacobson's organ analyzes molecules on its tongue, while its nostrils sniff more conventionally. The rattlesnake can taste her target before she even sees it. And in the dead of night, no one sees bats coming, as they ping their prey with ultrasound, pulsed sounds that are loud to bats but undetectable to us. It leaves their prey no place to hide. While jumping spiders look before they leap, counting on their 8 specialized eyes, calculating their distance by their excellent 3D and color vision. The echidna, primitive in so many other ways, manages to detect electricity through hundreds or even thousands of receptors in her snout. As a backup, other cells in her snout detect movement. And humpback whales use some of the lowest frequencies in the animal kingdom to coordinate their hunts, breeding, and migration. They pick up each other's sounds not through their ears, but through their jawbone. These extraordinary talents, bestowed by nature, comprise the animal kingdom's elite core.